Hola, ¿qué pasa? And this is not a Spanish tutorial, but this is actually an English tutorial, that is tutorial in English, about the Linux operating system. And today we are going to talk about the kernel. We are going to zoom in on the kernel and talk about what are its responsibilities. So before we even talk about what are the responsibilities of the kernel, let's talk about what kernel actually is. So the kernel is the core of the operating system. So if I were to write the operating system, or if I were to represent the operating system as this big circle, this little small circle on the inside would be the kernel. Okay, so this on the inside would be the kernel, and this other stuff would be some other stuff. But basically, the kernel is the essential element of every operating system. And today we are going to talk about what does it do? What is the purpose of the kernel? Well, the kernel manages four things, and let me list them here. So the first thing the kernel manages is processes. Then the kernel manages memory. And then I'll explain all of those. Then the kernel manages device drivers. And then the kernel manages system calls. Okay, and I will explain each one of these in turn. So let's first talk about processes. And the purpose of the kernel in regard to processes is starting, pausing, resuming, and terminating processes. And if you are wondering what processes are, you can think of them as your applications. So if you're going to be using Mozilla Firefox or whatever else on your Linux operating system, or even on Windows operating system, you have this concept of processes. And again, you can think of them as your applications that you use every day. So the kernel starts, pauses, resumes, and terminates processes. The kernel is also responsible for giving processes the hardware they need to execute the thing they were programmed to do. As we talked about in the last video, you program instructions for the hardware to execute. That's why we need hardware, and to emphasize it, we need hardware to actually perform the calculation the programmer intended it to do. The kernel decides which process gets what hardware at what time. As there are multiple processes, or you can think of it as multiple applications for now, running at the same time on your computer. For example, you most likely have a web browser open, as well as a file explorer, as well as something else. Okay, then let's talk about memory. Memory is the thing where your programs are actually stored. So these applications that we talked about, processes, actually need to have their memory. And the kernel makes sure to give memory to a process, check if the process is only accessing its own memory and not some other process's memory. And it is also responsible for cleaning up the memory after the process terminates. And when I say memory here, I mean RAM, that is random access memory. Think of RAM as storage space. Every program is stored in the RAM as it is executed. The kernel makes sure to give each process enough RAM and to free up the RAM when the process terminates so other programs can step in the newly vacant storage space. And basically, to visualize memory, let me just draw something here. Let me just move down here or wherever, just so that I have clean space. And so your RAM, random access memory, is where your programs need to be stored. Okay, so this is going to be the RAM. We're going to talk more about memory related stuff in other videos or other tutorials, but basically what happens is when you have a process or an application, it takes a certain part of the RAM. And let's say that this part of the RAM is taken up by Firefox, and let's say that this part of the RAM is taken up by, I don't know, LibreOffice Writer or whatever, so LibreOffice Writer. And so what happens is when you have these processes running, they're taking up a certain space in the RAM. And let's say you click X on Firefox, which means you exit Firefox, then this space becomes free and it becomes available for other processes to use. And the kernel has to manage that. And so why is it important, and this is a really good question actually, why is it important for the processes not to access other processes' memory? So for example, why is it important that Firefox doesn't access LibreOffice Writer's memory? Well, if it writes to other processes' memory, so if Firefox writes to other processes' memory, it could overwrite some data which may be really important for that process, which would be bad. So either accidentally or on purpose, it could overwrite some data which could be really, really bad. There are other reasons, but since I'm not a professional at information security at this point, I feel unqualified to talk about it. Then let's talk about the third point, which is device drivers. So the kernel manages the device drivers. Remember those things you have to install every time you install a new Windows on a computer that enable you to use some hardware, for example, your speakers? Well, two things about that. Number one, you, in most cases, don't have to install drivers on Linux as they come pre-installed, so switch to Linux. And then number two, device drivers make it easy for programmers to talk to hardware. Now, how is that? We touched upon this in the previous video, but how is that? Let's say I wanted to write some files to a hard disk. If I had a Samsung hard disk drive and you had Seagate hard disk drive, the code for writing to Samsung hard disk drive versus writing to Seagate hard disk drive, and Samsung and Seagate are just brands of hard disks, would most likely be different since they would have different hardware responsible for the task of writing to the hard disk drive. And again, we touched upon this in the previous video. Operating system allows me not to worry about the details of the hardware. So not only does it serve as an intermediary, as we discussed in the previous video, but it also allows me not to worry about the details of the hardware. So instead of saying to the operating system, write this to the Samsung hard disk drive or write this to the Seagate hard disk drive, I just say write this to the hard disk drive, and the operating system takes care of the specifics of the hardware. And then let's discuss system calls. So system calls call the kernel to do something for them. For example, from my program, which is, let's say, Firefox, I first tell the operating system, write something to the hard disk drive. And so to visualize this, we had that image in the previous video, but let's write it up again. So let's say I have Firefox here, and let's say I have the kernel here. But again, you do understand that the kernel is just a part of the operating system, and to emphasize it, I'll just write a bigger box. So this entire big box is the operating system. Firefox is just a piece of software that we are running, and then we have the hardware, and in this case we have the hard disk drive. And so basically what is happening is Firefox is telling the operating system, write something to the hard disk drive. So it's telling the operating system, write. And then the operating system kicks in and the kernel takes over and writes the information the Firefox told us to write to the hard disk drive and gives me some feedback on how did it go. So basically, write operation is actually performed here. Then the hard disk drive indicates, was it a failure? Did it write correctly, etc. And then the operating system gives us the information about how did it go. So roughly speaking, this is how it looks like. And the feedback information contains answers to the questions such as, was it successful? Was it a failure? If it failed, why did it fail? And again, those are some things that the operating system, more specifically the kernel, handles for me. And so in addition to this explanation, there are some terms frequently used when talking about process management. And again, the kernel manages processes. And I will list those in the description, in the video description. So if you're interested in those, feel free to check them out and read up on those concepts. Okay, so I really hope this was useful. I hope you learned what is the kernel responsible for. I hope this visual approach kind of eases things up and really makes you understand things much faster or much better than if I didn't draw this. And I actually think this drawing is actually pretty cool. Okay, so thank you for watching. I hope I'll see you in the next tutorial, and until that time, talk soon.